Today is the 29th.
Yeah.
So you said problem
51 on page 383.
51 on 383. 51. 51. Okay. So we're given a function, and I think I should get my pencil out. Can we see? Okay. So we are asked to put these numbers in, they say, increasing order from smallest to largest, and explain your reasoning. Okay. The integral from 0 to 8 from f of x dx. So 5, 6, 7, 8. So the integral from 0 to 8 from f of x dx is all this area. So there is some positive area and some negative area. So let's try and come up with a number. It's definitely going to be a positive number. Would you agree? So for now, I guess I haven't looked at all of them. So let's just look at all of them and then make a decision and then come back. Okay? So that will be the first one. And it's definitely a positive number. I'm not sure how much. We'll come back. The integral from 3 to 8. It's definitely a positive number. Let's compare. I don't know why I should have gone to B, but never mind. So which of these two is bigger? Obviously, the integral from 3 to 8 is bigger because there is no subtraction, no negative area. So if you want to compare the two, so obviously A is less than C. Okay, now the 0 to 3 from f of x dx is a negative number. I'll come back to it. Now the integral from 4 to 8, so 4 to 8 is definitely smaller than C, but bigger than A. Because see, A has some negative area. So this 4 to 8 is smaller than 3 to 8. So for now, if I were to compare A, B, C, and D, I would say I wrote it the other way around, didn't I? Okay, C is definitely the biggest for now. D will follow. A will be the next because I subtract all this area. And then B is definitely the last because it's negative. But I have not discussed E yet. I don't know where E fits in. But is this okay so far? Okay. So f prime of 1. So f prime of 1. So this is 1. And f prime of 1 will be the slope of this line. It is negative. I am tempted to say the rise is 2, so this, I'm going to say negative 1. Okay, so this is definitely smaller than negative 1, so I will put negative 1 in here. So I will say C, D, A, negative 1, and B. That's my opinion. Does it make sense?
It was just E that I was confused about. I didn't know how to...
Oh, f prime of 1 is the slope of the tangent. Okay.
I didn't know how to, like...
Okay. Okay, very good. Anything else? Good question. Anything else?
Look at 37.
Same page, 37. Let's take a look at 37. 37. Evaluate the integral by interpreting it in terms of areas. Okay, good. Is the same, 383. Okay, so we have the integral from -3 to 0, from 1 plus the square root of 9 minus x squared dx. Very good. Okay, So I need to graph this function, and first I would like, it's not a problem to graph the plus 1, right? But I want to graph this first. So if I look at y equals the square root of 9 minus x squared, and for a second, bear with me, I want to square both sides, then I have y squared equals 9 minus x squared, and I put it in the correct order. This is a circle with a center at the origin with a radius of 3. So this will be, don't graph it just yet because I did not add in the plus 1. I will do that in a second. So this is the graph of the circle. However, we are only talking about the positive. So I know that this will be the positive square root of 9 minus x squared. And I know that this will be the negative, right? So y is the square root of 9 minus x squared will be this. But I have to resume myself, or the graph, only between -3 and 0. So this is the graph of the square root of 9 minus x squared without the plus 1. Any questions so far? But now I have to add that plus 1 in, and then find the area, interpreting it in terms of, so here's the graph now, final graph. So I'm asked to find this area. I do have a rectangle that I see here. This area is definitely 3, length times width. And this area, this one, is 1/4 of a circle with a radius of 3. So the area of the circle is pi r squared. And in this case, I have pi r squared over 4, which will be 9 pi over 4. So now I can come back to my integral. So the integral will be this area of 3 plus this area, which is 1/4 of a circle with a radius of 3. So plus 9 pi over 4, whatever that is. Is this clear, Ben? Any questions? Any questions, anyone? Yes, Tony?
The page before 3 to number 5.
Yes. Number 5. The graph of a function f is given. Estimate the integral from 0 to 10 f of x dx using 5 subintervals with right endpoints, left endpoints, and midpoints. You just have to estimate from the graph.
Okay.
You just have to say the first subinterval would be from, so we have 5 subintervals between 0 and 10, so you will have, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so the whole thing, okay? So with 5 subintervals, the leftmost, for the leftmost point, you will have base of 2 times the height of f of 0 plus base of 2 times the height of for the leftmost point will be f of 2. And you will have to determine them from the graph. You don't have anything to plug in. You just have to estimate all these numbers from the graph. It will be an approximation, of course. Is that good enough?
Yes.
Okay. Anything else? Other questions for me? Anything else? Anything else? Okay, so I can come back. If you find something, I'll go back to what you need. Since we already talked about this, because we used it last time, I would like to continue with 5.3. Section 5.3, you have the handout. Thomas, you need one?
Yeah.
So here it is. It's right here. I just need to look for another for me. Right here. Okay, so let's start with part 2 because we already used it so many times before. And then we come back to Fundamental Theorem of Calculus, part 1. So let's read it now. Second page of 5.3. If f of x is continuous, that's mandatory, on the closed interval a comma b, then the integral from a to b from f of x dx is what we just used. The antiderivative of f of x, and notice the uppercase f, evaluated at b, minus the antiderivative of f of x, evaluated at a, where f of x is any antiderivative of f of x. This says to evaluate the definite integral is to evaluate a definite integral, subtract two values of an antiderivative of f of x. I subtract. That's what I'm doing. I subtract the values of the antiderivative at two different values of f of x. In other words, I'm saying f of b minus f of a. Okay, so we have here a few examples, and let's work through these examples using the Fundamental Theorem of Calculus Part 2 that we studied last time already. And Ian takes credit for that. So 5.2, so let's say the integral from 0 to 2 from x squared plus 1 dx. Can anyone walk us through? There is no need. But yes, you can. That's one of the properties of the integral that we just reviewed. Yes. So what is the antiderivative of x squared?
3x over
X to the third over 3 plus, what is the antiderivative of 1? X between?
0.
Very good. So lucky me, I don't have to plug in 0 because it's going to be 0. So let's plug in 2. 8/3 plus 2. Find the least common denominator to be 3. 3 times 2 is 6. 6 plus 8, 14. Any questions?
So it's just about the antiderivative of the original function and then plug in 0.
Exactly. Exactly. But subtract them in this order. Applying the top limit minus when I apply the bottom limit. Exactly. So let's look at the next one. The integral from -3 to -1 from 1 over x squared minus 2x plus 3x squared dx. And that's why I tortured you with this a long time ago and continuously. What function prime is 1 over x squared with some minor change? Exactly. So when I differentiate 1 over x, I get -1 over x squared. But since I don't have the negative here, I have to have it here. Excellent. Minus 2. Which function prime is x? Over 2 plus which function prime is 3x squared? Excellent. From -3 to -1. Very good. Let's simplify first, and then we plug in the top limit minus when we plug in the bottom limit. So negative 1 over x minus x squared plus x cubed, from negative 3 to negative 1. So now carefully let's plug in negative 1. So I have 1 minus 1 minus 1 minus, put parentheses to be on the safe side, plug in negative 3. 1 over 3 minus 9 minus 27. Any questions before we continue? Is this okay? Now I have to perform the calculations and simplify as much as possible. Well, these two go away. And then I have the negative 1 minus 1/3. And this is 36 because I have minus and minus. So plus 36. 36 minus 1 is 35 minus 1/3. Least common denominator 3. 105 minus 1. 104 over 3. Okay? So the integral from negative pi over 4 to pi over 4 from secant squared x dx. Which function prime is secant squared? Very good. From negative pi over 4 to pi over 4. I plug in the top limit, minus when I plug in the lower limit. Anyone remembers tangent pi over 4? One, right? Tangent pi over 4 is 1, minus. Tangent negative pi over 4 is? Exactly, with the minus in front? Yes, so the answer is 2. Excellent. Well done. Okay. The integral from 0 to 3 from f of x dx. Any questions from me, please? And we are given this function in the form of, what type of function is this? Very good, excellent. So this is x squared if x is between 0 and 1, and it's 2x minus 1 for x between 1 and 3. What do you think we will need to do here?
What else do you know?
Very good. Please dictate and I will write it. Ready. Excellent. Very good. dx. Very good. Awesome. Excellent. From? That's it. Awesome. Which function prime is x squared? Very good. From 0 to 1. Plus. Which function prime is 2x? Excellent. Minus which function prime is 1? From 1 to 3. Excellent. Luckily, the first one I only plug in 1, because when I plug in 0, I get nothing. This I simplify. Plus, I plug in 3 first. 9 minus 3 minus. I put parentheses so that I don't make a mistake that I have to subtract now the value of the antiderivative at 1. So I plug in 1, 1 minus 1. That is 0. So 9 minus 3 is 6. So I have 6 plus 1/3. 18 plus 1, 19/3. Last one here. All this procedure is called Fundamental Theorem of Calculus Part 2. In some books, they'll call it Part 1. It doesn't matter. It's one of the two parts of the Fundamental Theorem of Calculus. Last one, the integral from 0 to 1 from x to 3 over 7 dx. Yes, Tony?
Firstly, what's the difference between this and then evaluating the integral?
Very good. When we are asked to evaluate an integral, you're asked to find the answer. So most probably you will be asked to evaluate the integral when you are given a definite integral. However, sometimes they will say evaluate the integral, but it's an indefinite integral. So you'll find a function.
Okay.
So you have to find the integral, depending on what it is. It could be an indefinite or it could be the definite. If it's a definite, you have to come up with a number.
Okay.
If it's an indefinite, the answer has to be a function plus c.
Got it. Okay.
Yes, that will be the next step.
Okay.
That will be the next step in the next section. We're going to look at that. Okay. So what function prime is x to 3/7? X to 3/7 plus 1 over 3/7 plus 1. Yes. From 0 to 1. Luckily, I don't even have to calculate that up there because when I plug in 1 is 1. When I plug in 0, it's gone. So the top is 1 over 10 over 7, and I have to flip it. Now I want to give an example like this. What will you say about this? I'm asked to evaluate it. Very important to remember this. This is a tricky question. The function must be continuous on the given interval. Let's look again. Is 1 over x continuous on -3 to 4? Because it's undefined at 0. And the answer is Fundamental Theorem of Calculus not applicable. No. Fundamental Theorem of Calculus not applicable since function is not continuous on the interval -3, 4. You will see what happens in Calc 2 with these. Okay, I think we are ready now to go back to the Fundamental Theorem of Calculus Part 1. So, in general, the Fundamental Theorem of Calculus has two roles. One establishes the connection between the tangent problem and the area problem, which you will see in a moment here with Part 1. Also, it shows the area problem is the definite integral. It shows that differentiation and integration are inverse processes. What does that mean? If I have a derivative and I integrate it, I get the function. If I have the integral and I differentiate the integral, I get the function back. So here's the an example that I wanted to work on, but it's not here. I put it here. Sorry about that. Okay. So I claim that the integral from dx over this equals x over 9, the square root of 9 minus x squared plus a constant c. This is my claim. You can say, how did you come up with it? In a moment, I'll explain. So I claim that the integral from 9 minus x squared raised to 3/2 is the same with x plus 9, the square root of 9 minus x squared plus a constant c. This is not an indefinite, this is not a definite integral. I would have not been able to show you that differentiation and integration are inverse operations with a definite integral. For example, with this, I cannot show anything here because this results to be into a number. It's a number. I cannot show you that this is correct. I can show you doing it step by step, but I cannot check in any way other than showing you that this is correct. But if I start here and end here, I have to show you the intermediate steps. I cannot differentiate. That will not work for a definite integral. Here, I claim that this indefinite integral has this function, the most general antiderivative, this. But I have a way of showing you. Remember when we had to differentiate implicitly because we could not solve an equation for y, right? So what did we do? We differentiated both sides. Agreed? I can always do that. Well, this is what happens. When I differentiate an integral, this, and of course this, which is part of the sum, go away. The differentiation eliminates the integration. So the left-hand side is 1 over 9 minus x squared raised to 3/2. Now I don't know what I'm going to get on the right-hand side. So I have to differentiate the right-hand side. But I prefer differentiating this, 1 over 9x times 9 minus x squared to -1/2 plus a constant c. Because it's easier than having that square root in the denominator, blah, blah, blah. So I have 1 over 9. I have x, which has to stay at the top. And I brought this quantity to the numerator with a -1/2 power. So now I'm going to differentiate the left-hand side. It's a product. Obviously, when I differentiate c, it's 0. So I'm differentiating this as a product, and 1/9 can wait. I'm not going to involve 1/9 in anything. First function prime is 1 times this, 9 minus x squared raised to -1/2, plus x times this prime, which is -1/2, 9 minus x squared, of course I ran out of room, raised to -3/2, times the inner function prime, which is -2x. Should I write it one more time because it's not clear? Yeah, it's not clear. Okay, let me write it one more time. Forgive me. So I'm going to write it here. So 1/9 stays in front. First function prime is 1. So I copy 9 minus x squared raised to -1/2 plus. I copy x, and now I have to differentiate the second function. -1/2, 9 minus x squared raised to -3/2. I have to subtract 1, multiply by -2x. It's the same in there, but it's not clear. Okay, so now I will have to multiply this and this and this, and I will have to factor out 9 minus x squared raised to -3/2. -1/2 minus -3/2 is 1. This is completely out. -2x times x is -2x squared divided by -2 is positive x squared with 2. Sorry. So 2x squared divided by, so it's -2x squared divided by -2. Oh, right. It's divided by -2. So therefore, because it's divided by -2. So then -x squared with positive x squared go away. Then positive 9 with -9 will simplify. And look what I get. I'm going to erase that. 1 over 9 minus x squared raised to 3/2. So what am I trying to show you with this example? I'm trying to illustrate an example in which we show that This is not the proof, but this is an example in which we show that differentiation and integration are inverse operations. So if I differentiate an integral, I get the function. If I integrate the derivative, I get the function, because the operations will cancel each other out. And this is illustrated in the fundamental theorem of calculus. So what is this part 1 all about? So let's talk about it. Of course, f of t is a continuous function. I need to show you with a graph before we read this, because it's by simply reading it is not clear. And then I'll come back to the handout. So let's take a look at this situation. Here is the interval a comma b, very familiar by now. Here is a function which this time is f of t. So in the coordinate system t, f of t, I have the interval a comma b, and I have a function that is continuous. It has to be continuous on the interval a comma b. Now, can anyone tell us what is this and how will you write it? The integral from a to b from f of t dt. And this is nothing else but the area. Would you agree? So I shaded in the area under the graph of f of t between a and b, which will immediately be represented by the integral from a to b from f of t dt. Is this okay? Agreed? Okay, here's what I want to do next. Somewhere between a and b, I'm going to come up with x. And you can say, but you have t here. What is this x all about? I'm going to say that x is a value that goes, a number that goes anywhere between a and b. Okay, and now I'm going to ask you how to represent this. What does this mean? The Bordeaux area. I don't know. Say it again. The integral from a to x. Awesome. So this is, I'm going to call it a1. Awesome. Now, bear with me. Now, I'm going to say that this is x. So let's say this was x1. And now I want x2, so then I have to put x1 here. I want x2, and now I want somebody to give me the red area. Okay, and I can continue forever, right? For x equals a, between x equals a and x equals b, I can continue and find this will be a number. This will be another number, and I can continue forever till I get to the whole thing, right? The integral from a to b from f of t dt. Correct? Okay. So if x is a, I will get a number. If x is bigger than a, whatever you want, I get another number. If I get a third x, I'll get another number. If the next x, another number, till I get to b. What am I creating? If for each x value between a and b, I get a different output, what am I creating? Every time I put in an x and I get a different y value, what am I producing? Exactly, I am producing a function. So, the integral from a to x from f of t dt depends on x. If x is x1 and then x2 and then x3 and then x4 and then x5, it depends on x. So this is basically a function defined as an integral. So we will call this g of x. So we have so many different ways of creating functions. This one was determined using an integral. How? By simply saying that for every x value between a and b, I have a different output. So for every x, this will be a different number depending on x. In such a situation, for this particular case, we're not going to be able to determine anything. We will only, as a value, it's a function. All we can do is determine the derivative of this function. So how do I do that? By differentiating both sides. So the left-hand side is g prime. But now let's think what is the right-hand side. The answer has to be a function of x.
Is the x between A and B?
X. Is that the question?
No.
Yes, yes. X is between A and B. So I differentiate the left-hand side, I got g prime. Can you tell me what we get on the right-hand side? Of course, this operation will take care of this operation together with this. But the right-hand side must be a function of x. What do you think we'll have on the right-hand side? If this is gone, and this is gone, and the right-hand side has to be a function of x, what will you say we should write? Give it a shot. Say it again.
F of x?
Exactly. We differentiated the integral. So we got f of x. The correct, 100% correct answer should be f of x multiplied by the inner function prime. But why we don't need it is because x prime is 1. What if I have the following? What if I have g of x equals the integral from 8 to, let's say, tangent x from f of t dt? Now, I can only be asked to find the derivative of g. So let's differentiate the left-hand side and the right-hand side. I get g prime of x. What do I get now? I don't have x. I have tangent x. I have a function of x. I don't have pure x. This. So this operation will eliminate this operation and together with this, and I have to obtain a function, this time of tangent x times the inner function prime. So what will you say? Give it a shot. F of, I don't have x. I don't have t. Yes. It's exactly the same mechanism. Is replacing this by this, but I had x and x prime was 1. So this is not sufficient. It's times. Exactly. Exactly. Okay, let's look at a few examples, and we'll come back and fill it in. So let's say we are given f of x equals the integral from 0 to x, a simple one first, 2t plus 6t squared dt. Remember, we cannot be asked anything else but to find the derivative of uppercase f. Okay, so we differentiate the left, we differentiate the right, and f prime will be exactly plus 6x squared. I'm differentiating, I'm not finding the integral, I can't. It's a function. Okay? times the inner function prime, but that is 1. This is it. We cannot find the integral. We are only differentiating. I'm sorry?
All you do is just change the t for x.
G prime of x is f of x. So when I differentiate, this is a function. When I differentiate, this operation takes care of this, and all we have to do is replace t by x. Yep. So g of x, the integral from 1 to x squared, cosine squared t dt. We are only asked to differentiate, to find g prime. So then g prime, we differentiate the left, and we differentiate the right. What do I have on the right-hand side? I want to show you, just to make sure that this is clear. This must be a number. This must be a number. This must be a number, and it is. Good, so g prime of x. Say it again.
F of x. No, I'm sorry. To cosine.
Say it again.
Squared.
Times the inner function prime. That's it. Perfect. G of x, 0 to 1 over x squared from sine cubed of t dt. We're asked to differentiate. The left-hand side is g prime. Now carefully give me the right-hand side. Excellent. Times the inner function prime. You don't know? No, you have to take it on the side. So this is x to negative 2 prime is negative 2 x to negative 3. So multiplied by, and I will put it in front, it's better, safer. So negative 2 over x cubed. Okay, I want to show another problem before the last one on this page. Let's say I have the integral from sine x to 5, and this is my function g of x, from tangent squared x, I'm sorry, tangent squared t, it has to be t, dt. And I'm asked to find the g prime. One more time, this is a function given in the form of an integral, but it's a function, because for every x, I get a different number. I see a minor problem here. What is the minor problem here? So what is the problem? The problem is that the lower limit is not a number. But definite integrals have a property. What happens when I do that?
And so change the sign.
Exactly, I have to do that first. So then g of x is basically negative the integral from 5 to sine x tangent squared t dt. Now I'm safe. Now I can apply fundamental theorem of calculus part 1, and I'm allowed to differentiate both sides because I'm asked to, actually. I'm asked to find g prime of t, g prime of x, minus. Remember, we are differentiated the integral, we just get the function.
Tan squared sine x.
Times the inner function prime. If this were x, I would have not have to write anything else. This shows us that when we differentiate an integral, we get the function. Because differentiation and integration are inverse operations. They cancel each other out. Now we are ready for the last one. So the last one is the integral from 1 over x to x cubed from, same thing, sine cubed t dt. Another problem here. Right, because in the sense that I have both limits, the lower limit and the upper limit are functions. Okay, but we do have a property that we discussed last time. Not we, definite integrals. Have a property that we discussed last time, which is the integral from a to c from f of x dx is the integral from a to b from f of x dx plus the integral from b to c from f of x dx. I can split any integral in as many parts as I want. So I'm going to split this integral first and say the integral from 1 over x to whatever number you want from sine cubed t dt plus the integral from that particular number, whatever you want, to x cubed sine cubed t dt. You can put literally any number you want. You can put 0, you can put 1, you can put whatever you want. I don't even bother with it. So this will be okay. But this one needs one more step. What do I do to this one to make it ready? Swap the limits, right? Now we're ready to differentiate. Going to differentiate the first, the beginning, and the last. F prime of x. Can anyone give us? Because we know we can differentiate a sum, no problem there. So please tell me what to write as the first part. Negative, definitely. Sine cubed of sine cubed of, very good, times the inner function prime. We know this formula for a long time now. Very good, negative 1 over x squared, plus I reach this, what? Of, excellent, times the inner function prime. That's it. This is it. This is the derivative of the function given in the form of this integral. That's its derivative. Okay, now we're ready to come back and so let's look. Any questions? Any questions? So f of t is a continuous function. As we know, t is between a and b. And f of x is defined like this in the form of an integral. Then when we differentiate both sides, the left-hand side is f prime and the right-hand side is f of x for x between a and b. This means that if f of t is positive or 0 and t is between a and b, then the area under f of t between a and x is given by an integral of f of x. is given by an integral. Unfortunately, I did not copy the graph here. I was just looking. I have to, so sorry. I forgot to copy the graph. It says, if f of t is the function whose graph is shown below, and I forgot to put it in. So my apologies. So we can look for a problem like that from the book. But in the meantime, let's continue. And we already talked about this, the indefinite integral, but we have not really looked at problems yet. So let's take a look. And also here, when I was coming up and I looked, so for some reason the 1 disappeared on page 3. I don't know why and how it was gone. Okay, so the integral from f of x dx is the indefinite integral of f of x. And as we know from before, f prime of x, uppercase f prime of x equals f of x from here. And this will be very clear to you in a minute when we look at examples. So let's look at these examples. Ready? Okay. Find the following indefinite integrals. So let's start with the first one. What is the answer of an indefinite integral? And I can always check what is the answer when I find an indefinite integral. Like the integral from x to 2/3 minus the square root of x plus x to -3 dx. And this is section 5.4. The indefinite integral. So what do I get when I determine an indefinite integral? A function. Very good. So let's find that function, and if we have any doubts, we can always go back and check. Which function prime is x to 2/3? Well, it's x to 2/3 plus 1 over 2/3 plus 1. This is x to 1/2. So minus x to 1/2 plus 1 over 1/2 plus 1 plus x to -3, x to -2 over -2 plus a constant c. Yes, it needs some cleaning up, but if you want to check that this is indeed these equals the right-hand side, how would you check? By differentiating both sides. When you differentiate this side, what will you get? You will get this, the function itself. Because when I differentiate an integral, I get the function. What will you get here? Well, when I differentiate, I should get that. And we can check, but let's clean it up first. 2/3 plus 1 is 5/3. When I flip, I get 3/5. X to 5/3. 1/2 plus 1 is 3/2. So it's 2/3. And x to 3/2. And then minus 1 over 2x squared plus a constant c. It's completely cleaned up. Would you like to check whether this is true? Yes? Okay, very good. So let's say we want to check. I differentiate the left-hand side, and I differentiate the right-hand side. When I differentiate the left-hand side, what do I get? This operation eliminates this, and I get the function back. So the left-hand side is x to 2/3 minus the square root of x plus x to -3. Now I'm differentiating the right-hand side to check and see that I get the same thing. 3/5 times 5/3 times x to 5/3 minus 1, which is 2/3, minus 2/3 times 3/2. X to 3/2 minus 1 is x to 1/2. And minus 1/2, this is x to -2. -2 times x to -3. And the constant prime is 0. So these are 1, these are 1, and these are 1. So what did I get? X to 2/3 minus x to 1/2, which is this, plus x to -3, which is this. So they are the same. Which I cannot do with the definite integral. Any questions? Okay, let's look at the next. The integral from y minus 3 to y plus 5 dy. We're asked to find the indefinite integral. Would you like to work on this for a minute? What would you do first? We're asked to find the function. I don't have the function. I can differentiate. I differentiate when I have both sides. If I don't have both sides, I can't differentiate. You can't because it's a product. But you are on the right track. Eventually, that's what I want to find. Absolutely. But what will be the first step before I get to that? I don't know how to integrate a product. So what will I do first? Of course. So please do some algebra. Distribute quickly, take the integral, and find the function, please. Of course. If I don't distribute, I won't be able to determine the antiderivative.